So let's do a few more electron configuration examples for elements that have quite a few electrons. Palladium, we need 23 electrons. Starting at 1s2, we'd have 1s2, 2s2, 2p6, 3s2, 3p6. We're following the off-brow principle. I'm now up to 18 electrons, getting close. Next is 4s2. Now my n-1, 3d, and I only need 3 more electrons, 3d3. Always a good idea to add up all the superscripts to make sure that you get the 23. What would this look like if we did an orbital diagram? I would have the same order for entering my orbitals from low to high energy, but whenever I have an S shape, I only draw 1. P shape, I'm drawing 3 orbitals, and when I draw the D shape, I have 5. Now I'm going to just fill in all of my electrons, following Hund's rule, so that when I get to my last 3 electrons, we are filling 1 per orbital. We are not doubling up until we are forced to. Let's do another example. How about hafnium? Atomic number 72, which means we have 72 electrons. So we're going to start and follow our pattern that we see on the periodic table. This would give us 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now I'm going to be careful as I enter the D part of the table, n-1, so that would be 3d10. Then we're back to the P section on level 4, so 4p6. Now I'm dropping to 5s2. The n-1, so 4d10, 5p6. We drop to our next row. We are at 6s2, and now we need to really watch. We're going at 56. We're dropping to the lanthanide, the F part of the series, so that would be n-2 for 4f. We need all of them. 4f14. We're back up to the 5d part of the table, and we count 1, 2. We need 2 more electrons, and we are done. Always a good idea to add up all the superscripts, as they should add up to 72, to up there, adding all the way through. We get 72 electrons. We know that it is indeed correct. If you're off by 14, that would be a big reminder that you forgot to drop to the F part of the table. All right, now let's write, or rather let's draw the orbital diagram instead of the electron configuration. We will draw and put the identification for the particular orbital underneath, reminding ourselves that whenever we have p orbitals, we will have 3 of them. When we have the S shape, we only have 1. When we have d orbitals, we will have 5. And when we have f orbitals, we will have 7. Continuing, I would have all my orbitals drawn as shown, showing the coefficient with the energy level and the letter shape as the orbital beneath our boxes. And even though I know as my very last orbital, I'm only filling in 2 electrons in the D. Whenever I have a D orbital, I still draw 5 orbitals. Now we're going to go back and fill in all of our electrons, remembering to follow Hund's rule. And after I have all the electrons filled in through the 4F, I'm remembering following Hund's rule as I add the last 2 electrons. It's going to be 1 single in each of the first 2 5d orbitals, so that we don't double up until we are forced to. And again, that occurs because of stability. Electrons don't want to share a space if they don't have to. So we see that as the atomic numbers get higher and we have more electrons to show in our electron configurations, this gets to be a little tedious. So the good news is our next lesson will demonstrate a shortcut that can be taken.